Hello guys, welcome to Starper Tutorials. In this session we'll be discussing about this tower which is almost 1200 inches in height and triangular in shape and is connected with 6 cables subjected to 3 load cases. So we'll be analyzing it in StatPro. So let us begin the session. Initially start StatPro. Now we'll select new project, select space, give structure name, and units will be inch and pounds as per the figure. Select next, select finish. Now you can see this is a grid in inches, and what we have is this height is in y direction and the triangle is in xz plane, but we have here the grid is in xy plane. So what we'll do is we'll edit the grid to xz plane and we'll give 60 by 60 grid. So now we have 60 by 60 grid. First we'll select, since the triangle is, you can see the tower triangle, as you see, let me show you. See here the triangle, it is exactly 60 inches. The sides are 60 inches, which is 15.24 meters. So let us select the 60 inches first along x-axis. Now select escape. Now what you will do is, since you have this 60 inches length, you will edit and go to skew, select 60 degrees, select OK for explain. Now once again you will be plotting from 0 to some length up to some length. Select escape. Now you can switch off the grid. So you see this is a bigger in size. Now select the beam, select insert node, select 60 inches as the point, select add point, select OK. Now you can see this is 60 inches, this is 60 inches. You can delete this part and going to geometry you can select add beam point to point, select the both points. Now you go to dimensions icon, select dimension to view. So you can see 60 inches in all the directions. Since now first we'll do is we'll select all the beams, go to geometry, translational repeat, number of steps will be 1, default spacing is, the tower is total 1200 inches in height. Let me show you. So here it is 600 plus 600, 1200 inches in height, and number of bays are 20. So we'll have the default spacing as 60. Select link steps, select OK. Okay, you need to select in y direction. So you can see this is a part of the tower being created. So let me align it, rotate it a little bit so you can see the 3D view. This is the front view, top view and 3D view. Now we have braced angles which are members. Go to geometry, select add beam point to point. In this way we will add the braced members to all the 3 faces of the triangle form. So as you can see from top view it looks like this, front view, 3D view. Now what we'll do is we'll select the whole structure, go to geometry, run translational repeat, We'll select number of steps as 19 and select default spacing as 60 inches in y direction. Select OK. So you can see here it is created for you. So let us see, this is 5, 6, 7, 8, 9, 10. Okay, exactly 20 bays are created. You can remove the dimensions to view. And you can switch on the grid and go to edit and select X5 plane in order to view it in X5 plane and remove the skew. Okay, so now you can see the view of the tower exactly what we wanted it. So now you can see this, there are 3 node points at the bottom, and exactly at 1165.36 inches there are node points which are created for connecting cables. So what we'll do is we'll select node cursor, so as you can see the bottom node is selected, which is exactly in one direction. So you can select copy, select paste node, okay, so this will be a little bit difficult. We'll go to once again XZ plane, select this node point and select copy. Now select paste nodes in exactly X direction positive it will be, and the length in inches it would be 1165.36 inches. Select OK. So you can see there is our node point. Coming to this point, select copy node, select paste nodes, exactly minus 1165.36 inches. Select OK. So on the other side it is selected. Now the top view shows that we need one more node on this direction, which will be exactly Z direction. So what you'll do is you'll select the node using node cursor, select copy, select paste node in exactly Z positive direction 1165.36 inches. Select OK. So you can see the three nodes being displaced exactly. And now we'll add a member. So the member will be, let us see, from this point to this point, and this point to this point, and exactly this point to the middle one, which will be 1/10 point. So we'll select here. Now going for the same point, then in 3D view you can see selecting adding from this point to the topmost node point, as we wanted it. Then exactly at this node point, select escape. Now you can view the 3D view. So this will be the cable members, and this will be the, what we say, tower as per our figure. So first, initially, let us say I'm going to member specifications. You select cable, you select initial tension, which will be as per our parameters given as initial tension is 3000 pounds. You can see cable initial tension 3000 pounds. Select 3000, select add, select, okay, let it be this. Now going to general, you can go to section database, select Indian, and we'll select is tube. Exactly what we require is pipe section, which will be 24 inches outer by 22 inches inner. Let us define the pipe 24 inches by 22 inches. Select add. Then we have a cable member. Well, exactly we have cable members in American code. However, we can define the cable member by selecting circle and giving it as diameter will be let me see, 1 square inch diameter. So this will be 1 inch diameter, which will be, area will be, this won't be 1 inch, we need to calculate that, since we have pi by 4 into d square as area of cross sectional area, and we need 1 square inch as cross sectional area. So we'll need 4 divided by 3.14, that is pi value exactly as the inches. So it will be 1.273885 inches. Select add, close. Now select the circle member and assign to those cable members. You can go to member specification, select cable, select 3000 pounds as, and select assign. Now select close. So now these members are cable members. Now you go to top view and select the 3 members that will be selecting the entire tower, assign it to the entire tower. Fine. Now we are done with assigning. Next, going to support, creating a pinned support, selecting add, select pinned support, assign it to the bottom nodes. Okay, now assign to these 2 nodes too. Fine. Then going to load case details, you can see first one is 1000 pounds load, wind load at each node on windward face. Second one will be ice load. So let us see. So select load case details, select add, select load case. So select load case details, select add, select load case 1. And first load case we have is wind load. So select wind load, loading type will be wind, select add, close. Before that, however, for wind load you need to define definition, which will be wind definition. Select add, type will be 1. Now going to wind 1. So coming to wind load, it is 1000 pounds so let us select 1000 pounds and height will be 1200 inches. So you can even select calculate as per ASCE, and the exposure building structure will be a truss tower, and exposure you can give it category, select apply. Okay, now select add and the factor will be 1. Select add, plus assign this factor to all the nodes in the tower. Select assign, then going to load case details, select wind load, add, go to wind load, x windward, select 1, range will be 0 to, select 1200 or else 1500, let it be maximum, whatever it might be, 15 inches, 1500 inches, add, close. Well, you can see the wind load being assigned. Now going to second load case, it is a ice load and it is on each horizontal member. Select loading type as rainwater ice. Select add, close. However, going to wind load, in wind load you will have three categories of load. The other one will be Z windward and other one will be X windward. Factor will be -1. Now let me show you that Z windward load is applied in this from the other Z direction, and this will be, and there will be from X, and there will be from X. You can give Y range as 1500 inches. Same for the other wind load in negative X direction. Coming to load case 2, select add, go to snow load, so you can see at least one floor group needs to be present. So what we'll do is as per the figure, it is 50 pounds per foot on each horizontal member which will be acting in downward direction. So what we'll do is we'll add a member load which will be 50 pounds. As per the given figure, it is 50 pounds per foot, but we have here is 50 pounds per inches, so we need to calculate it. So 50 by 12, which will be exactly 1 foot equals to 12 inches, so 4.167 pounds per inches, so it will be 4.167 pounds per inches. Select add, close. Now in order to assign this, you select top view and select all those beam members. You can see, so the bracings do also get selected. So what you'll do is you select it separately. Anyhow, the bracings are getting selected. Let us try it another way. We'll select front view. Well, what we'll do is we'll select each beam. This is the only method we can do to assign. Now that you have selected once, So all those horizontal members are selected. Now assign to those horizontal members. Okay. Now coming to the third load case, which will be a combination. So select load case details, select add, select define combination. Now you will select wind load and the other load, ice load. Close. Once we are done with load case details, next thing will be going to design tab, coming to define parameters. We are using default values of our steel, and commands will be given are check code and take off. Assigning it to the entire structure, both the commands, then performing analysis. Select all, select, or else select no, print, select add, close. Now going to analyze, run analysis. Okay, the mistake we have done is we didn't select the particular code which is Indian code, so we'll delete the parameters once and for all. And now once again we'll go to design tab, select the IS code 800 and define the commands check code and take off. Then we go to check code and assign to the selected beams. Then we select analysis and print and run the analysis. There might be warnings, just make sure there are no errors. So now going to post processing mode. You can see that for the load case, combination load case, it is gonna be, the tower is gonna bend in this way, whereas for wind load you can see it is such a direction. You can even apply wind load separately. The reactions can be obtained, animation can also be seen as you see it. Going to modeling, you see if any failed members, cables. So the initial tension, the cables might not be sufficient. We will assign Go to see failed beams. You can see those cables are the failed ones. So the cable tension should just be increased in case to have the passed beams. However, in this way we are done with the tower, 20 bear tower. Reports can be obtained as usual. So this is the end of the session. Thank you for watching this video. Subscribe for more videos.